Download this code from codegive.com, link in the description below. Unleashing Potato Power, a comprehensive guide to boost FPS with master Potato graphics settings, with code snippets. This guide delves into maximizing FPS, frames per second, in games using Potato graphics settings. This technique sacrifices graphical fidelity to achieve a playable and responsive experience, especially beneficial for older hardware or demanding titles. We'll cover various aspects, from fundamental settings to advanced configuration files, and even touch on potential code tweaks. Disclaimer: while these settings can significantly improve performance, visual quality will be severely compromised. This guide focuses on maximizing performance above all else. Experimentation is key, and what works best will vary from game to game and system to system. Always back up your original configuration files before making changes. Understanding the philosophy of Potato graphics. The core idea behind Potato graphics is ruthlessly minimizing graphical load. This means lowest resolution smaller resolutions require fewer pixels to render, drastically reducing GPU load. Minimal texture detail lower resolution textures consume less VRAM and bandwidth. Disabling intensive effects shadows, reflections, anti-aliasing, and post-processing effects are performance killers. Simplifying geometry level of detail, LOD, settings control the complexity of objects at various distances. Lower LOD means simpler models rendered, further reducing the load. Reducing draw calls. Draw calls are instructions sent to the GPU. Optimizing settings to reduce draw calls is crucial for performance. 2. In-game settings, the first line of defense. Virtually every game offers graphics settings accessible through its options menu. These are your primary tools. 1. Resolution target lowest possible resolution that is still playable. Experiment to find the sweet spot. Consider resolutions like 640x480, 800x600, or even lower if your game supports it. Windowed mode can sometimes offer better performance. Explanation reducing resolution reduces the pixel count the GPU needs to render, drastically increasing FPS. 2. Texture quality target lowest setting, example very low, 1/4 texture size. Explanation lower texture quality uses less VRAM and requires less bandwidth, boosting performance. 3. Shadow quality target disabled or lowest setting, example off, low, fastest. Explanation shadows are very computationally expensive. Disabling them is a massive performance gain. 4. Anti-aliasing, AA. Target disabled, example off, FXAA off, TAA off. Explanation AA smooths jagged edges but is resource intensive. Disable it entirely. 5. Post-processing effects target disabled or lowest setting. This includes effects like bloom, motion blur, depth of field, and ambient occlusion. Explanation these effects add visual flair but significantly impact performance. Disable them unless absolutely necessary. 6. Level of detail, LOD, /view distance target lowest setting. Explanation controls the complexity of objects at varying distances. Lower settings mean less detail rendered at a distance, improving performance. 7. Effects quality target lowest setting, example low, minimum. Explanation controls the visual quality of special effects like explosions and particle effects. Lower settings reduce particle count and complexity. 8 vsync target try both on and off. If you experience screen tearing with vsync off, enable it. However, vsync can sometimes introduce input lag and lower FPS, especially if your frame rate fluctuates near your monitor's refresh rate. Experiment to see what works best. If you're consistently below your monitor's refresh rate with vsync on, you might experience severe stuttering. Explanation vsync synchronizes the game's frame rate with your monitor's refresh rate to prevent screen tearing. 9 full screen versus windowed/borderless windowed target full screen is generally preferred for maximum performance, as it gives the game exclusive access to the graphics card. However, borderless windowed might offer slightly better stability in some cases. Experiment to see what works best for your specific game and system. Explanation full screen usually avoids the overhead of the desktop window manager compositing the game's output with other windows. 3. Advanced configuration files, beyond the UI. Many games store their settings in configuration files, often .ini, .cfg, or .text files. These files often expose settings not accessible through the in-game UI, allowing for even more aggressive optimization. Important before editing any configuration file, create a backup, copy the original file to a safe location. Incorrectly modifying these files can cause the game to crash or become unplayable. 1. Locating the configuration files My documents/saved games Many games store their configuration files in a folder under your My Documents or Saved Games directory. Look for a folder with the game's name. Game installation directory The game's installation directory, example C /program files, x86, /steam /steam apps /common /game name, might contain configuration files. App data folder This hidden folder contains application data. You can access it by typing %appdata% into the Windows Run dialog, Win+R. The config files might be under local, roaming, or local low subfolders. 2. Common settings to tweak resolution Look for settings like resolution X, resolution Y, width, and height. Set these to your desired low resolution. Texture quality Look for settings like texture quality, texture resolution, texture detail. Set these to the lowest possible value. Some games use numerical values, example texture quality equals 0 for low. Shadow quality Look for settings like shadow quality, shadows enabled, shadow detail. Set these to 0 or false to disable shadows. Anti-aliasing Look for settings like anti-aliasing, AA quality, AA mode. Set these to 0 or false to disable AA. Load bias Load bias controls how aggressively the game switches to lower detail models at a distance. A negative load bias can sometimes improve performance by forcing the game to use lower detail models more often. However, a very negative bias can result in noticeable popping. Look for settings like R_load bias or LOD bias. 3. Example, editing a configuration file, general example, adapt to your game. 4. Example, editing the gamer profile.xml file in Crysis, extremely potato settings. Crysis is notorious for its hardware demands. The gamer profile.xml file, usually located in My Documents /My Games /Crysis allows for extreme tweaking. Explanation asterisk. Asterisk overall spec equals 1, this sets the overall graphics quality to low, 1. This alone can drastically improve performance. Asterisk asterisk quality spec equals 1, each setting, shader, texture, water, visual effects, shadows, etc., is explicitly set to the lowest possible quality. Asterisk mouse settings are tweaked to remove smoothing and acceleration, which can improve responsiveness. 4. Command line arguments, launch time tweaks. Some games accept command line arguments passed when launching the game. These can be used to override settings or enable debugging features. Common examples include *W width H height, specifies the window resolution, example W640H480. *xlevel version, specifies the DirectX version to use, example xlevel 90 to force DirectX 9. Using an older DirectX version can sometimes improve performance on older hardware. *no sync, disables VSync. *full screen, forces full screen mode. *windowed, forces windowed mode. *no pause, prevents the game from pausing when the window loses focus. How to add command line arguments, example for Steam. 1. Right-click on the game in your Steam library. 2. Select Properties. 3. In the General tab, click Set Launch Options. 4. Enter the command line arguments you want to use, separated by spaces, example W640H480 no sync. System optimization, beyond the game. Optimizing your operating system can further improve performance. 1. Update graphics drivers * ensure you have the latest drivers for your graphics card. Newer drivers often contain performance optimizations. 2. Close unnecessary programs * close any applications running in the background that you don't need, web browsers, music players, etc. 3. Disable startup programs * disable programs that automatically start when your computer boots up. These can consume system resources. Use Task Manager, Ctrl+Shift+ESC, Startup tab to manage startup programs. 4. Defragment your hard drive, HDD. If you are using a traditional hard drive, HDD, defragmenting it can improve file access times. SSDs, solid-state drives, do not need to be defragmented. 5. Overclocking, carefully, overclocking your CPU and GPU can provide a performance boost, but it also generates more heat and can potentially damage your hardware if not done correctly. Proceed with caution and research your specific hardware. 6. Lowering Windows visual settings * in Windows, adjust visual effects for best performance. * Right-click this PC on your desktop, or in File Explorer, and select Properties. * Click Advanced System Settings. * In the Advanced tab, under Performance, click Settings. * Select Adjust for best performance. This will disable most visual effects. 6. Code tweaks, advanced, use with extreme caution. This section is for advanced users who are comfortable with decompiling and modifying game code. Improperly modifying game code can render the game unplayable or violate the game's terms of service. Proceed at your own risk, Some games allow for modifying game code, example through DLL injection or patching. Here are some potential, but risky, code tweaks. 1. Texture replacements * replace high-resolution textures with extremely low-resolution or solid-color textures. This requires understanding the game's texture formats and file structure. 2. Shader modification * modify shaders to reduce their complexity. For example, you could simplify lighting calculations or remove certain visual effects. This requires knowledge of shader languages like HLSL or GLSL. 3. Draw call reduction ** attempt to reduce the number of draw calls by merging objects or culling objects more aggressively. This is a very advanced technique that requires a deep understanding of the game's rendering pipeline. Example: conceptual, requires game-specific knowledge. 7. Game-specific examples, brief overviews. 1. Minecraft ** options.txt * located in %appdata%\. Tweak settings like gfx_qual, gfx_fancy, and view distance. Use a resource pack with 1x1 textures for extreme potato visuals. 2. Gary's mod **. Console commands, use commands like mat_mipmap textures 1, r_shadows 0, r_dynamic 0, r_water expansive 0, r_draw particles 0, and cl_detaildist 0 in the developer console, key. Launch options, xlevel 81, force direct x 8.1. 3. Fortnite ** game user settings.ini, located in %localapp.a %\fortnite game \saved \config /windows client. Edit sg.resolution quality, sg.viewDistance quality, sg.anti-aliasing quality, sg.shadow quality, sg.post-process quality, and sg.texture quality, setting everything to 0 or 1. 4. Valorant ** set all graphic settings to low. Make sure multi-threaded rendering is enabled. ** in NVIDIA control panel, set the power management mode to prefer maximum performance. * lower your monitor's resolution. 5. Roblox * open the Roblox client. * press ESC to open the in-game menu. * go to settings, graphics quality. * manually set the graphics quality to the lowest possible setting. * set your rendering mode to Fukan or OpenGL. 8. Conclusion: the art of the potato. Potato graphics are about making a game playable on less than ideal hardware. It's a trade-off between visual fidelity and performance. By systematically reducing graphical load through in-game settings, configuration files, and system optimization, you can often achieve a significant FPS boost, making even demanding games playable on older or lower-end systems. Remember to experiment, back up your files, and understand the impact of each setting you change. Good luck on your journey to unleash the power of the potato. Unleashing the Potato, a comprehensive guide to max FPS with minimum graphics, boost FPS master settings. This guide dives deep into achieving maximum FPS in games, even on low-end hardware, by utilizing potato graphics settings. We'll cover everything from in-game configuration and OS tweaks to custom configuration files, and even some light coding examples to automate some aspects. The primary goal is to prioritize performance above visual fidelity, creating a playable experience where otherwise there might be frustrating lag. Disclaimer: the specific settings will vary from game to game. This guide provides general principles and examples that you will need to adapt to your specific game. Remember to back up your configuration files before making changes. Also, these settings may significantly impact the aesthetic appeal of your game. Understanding the trade-off *. The core concept of potato graphics is minimizing the demands on your GPU and CPU. This is achieved by reducing resolution *. Lowering the rendering resolution dramatically reduces the number of pixels the GPU needs to process. Asterisk minimizing texture detail. Asterisk low resolution textures require less memory and processing power. Asterisk disabling shadows. Asterisk shadows are computationally expensive to render, so turning them off yields significant performance gains. Asterisk disabling or lowering anti-aliasing. Asterisk anti-aliasing smooths out jagged edges, but it's a performance hog. Asterisk turning off post-processing effects. Asterisk effects like bloom, motion blur, depth of field, and ambient occlusion add visual flair but impact performance. Asterisk optimizing physics and particles. Asterisk complex physics calculations and numerous particles can strain the CPU. 2. In-game settings, the foundation. This is the most important step and where you'll spend the most time. Explore every setting in your game's graphics options menu. Here's a breakdown of what to look for. Asterisk resolution. Asterisk start with the lowest resolution available. If that's too blurry, gradually increase it until you find a good balance between visual clarity and performance. Consider using windowed mode or a lower aspect ratio, example 4:3, for further gains. Sometimes custom resolutions can be set via config files. Asterisk texture quality. Asterisk set to the lowest possible setting. This has a massive impact on VRAM usage and performance. Look for options like low, very low, or potato. Asterisk shadows. Asterisk disable shadows completely. If there's no option to turn them off, set the quality to the lowest setting, example low, fastest. Also, reduce shadow distance. Asterisk anti-aliasing. Asterisk disable anti-aliasing entirely, example set to none, off, or FXAA/SMAA, low. If you must use it, FXAA or SMAA are generally less demanding than MSAA or TXAA. Asterisk post-processing effects. Asterisk disable everything. Asterisk bloom. Asterisk motion blur. Asterisk depth of field. Asterisk ambient occlusion, SSAO/HBAO. Asterisk lens flare. Asterisk color grading. Asterisk chromatic aberration. Asterisk effects quality/particle density. Asterisk set to the lowest possible setting. This affects explosions, smoke, and other visual effects. Asterisk view distance/draw distance. Asterisk reduce the distance at which objects are rendered. This can significantly improve performance, especially in open-world games. Asterisk LOD bias. Asterisk this setting controls the level of detail used for distant objects. Negative values improve texture sharpness at a distance but increase GPU load. Positive values blur distant textures but improve performance. Setting it to a positive value, example 2, 4, 8, is a potato graphics tactic. This is often controlled via config file. Asterisk anisotropic filtering. Asterisk this improves texture sharpness at oblique angles. While not as demanding as some other settings, it can still impact performance. Set to the lowest value, example bilinear, or 2x. Asterisk VSync. Asterisk disable VSync unless you experience severe screen tearing. VSync synchronizes the game's frame rate with your monitor's refresh rate, preventing tearing but potentially introducing input lag and limiting FPS. Asterisk triple buffering. Asterisk disable this unless you're using VSync. Asterisk frame rate limit. Asterisk experiment with setting a frame rate limit slightly below your monitor's refresh rate. This can sometimes smooth out gameplay by preventing the GPU from constantly trying to render frames beyond its capacity, leading to frame drops. For example, if your monitor is 60 Hz, try a 55 FPS or 58 FPS limit. Asterisk rendering API. Asterisk some games offer a choice of rendering APIs, DirectX 9, DirectX 11, DirectX 12, Fukan. Experiment to see which one performs best on your system. DirectX 9 is usually the lightest, but can cause issues in modern systems. 3. Configuration file tweaks, beyond the GUI. Many games store their settings in configuration files, often .ini, .cfg, or .text files. These files often expose settings that are not available in the in-game menu. Finding these files usually involves searching within the game's installation directory or in your user profile's documents folder. Important: back up these files before making any changes. A simple copy and paste to a backup folder will suffice. Example: Counter-Strike, Global Offensive, CSGO, video.txt configuration *. CSGO's graphics settings are stored in video.txt, usually located in C/program files, x86, /steam /userdata /your_steam_id /730 /local /cfg. Here's an example of settings optimized for potato graphics. Explanation of CSGO settings * setting.cpu_level and setting.gpu_level, these control overall CPU and GPU usage. Setting them to 0 puts the least strain on your hardware. Setting.mat_anti-alias and setting.mat_equality, disable anti-aliasing. Setting.mat_force ISO and setting.mat_force texture sample, force anisotropic filtering off. Setting.mat_filter mode, set the texture filtering mode to bilinear, the least demanding. Setting.shadow_quality, disables shadows. Setting.shader_quality, sets shader quality to the lowest level. Setting.texture_quality, sets texture quality to the lowest level. Setting.defaulters and setting.defaultrescient, set the desired resolution. 640x480 is a common potato resolution. Setting.aspect ratio mode, defines the aspect ratio. Setting.mat_q_ mode, this controls the threading mode for material loading. -1 lets the game auto-detect the best setting. Experiment with other values, 0, 1, 2, to see if they improve performance. 2 is generally the best for multi-core CPUs. Setting.gpu_mem_level and setting.mem_level, set memory requirements to lowest possible. General strategies for configuration files *. Search for keywords *. Look for settings related to texture quality, shadow quality, anti-aliasing, resolution, LOD bias, post-processing, effects quality, particle density, view distance, draw distance, Boolean values *true/false, 1/0, or on/off settings often control features that can be easily disabled. Numerical values lower numerical values generally correspond to lower quality settings. String values look for options that specify texture quality or shadow quality, example texture quality low, shadow quality off. Experimentation make small changes one at a time, save the file, and restart the game to see the effect. 4. Operating System, OS, Optimizations ***. These tweaks can free up resources and improve overall system performance, which can translate to better FPS in games. Update drivers make sure you have the latest drivers for your graphics card, sound card, and motherboard. Asterisk close unnecessary programs. Asterisk close any programs running in the background that you don't need, especially resource-intensive ones like web browsers with multiple tabs open, video editors, or file-sharing applications. Asterisk disable startup programs. Asterisk prevent unnecessary programs from launching automatically when you start your computer. In Windows, use Task Manager, Ctrl+Shift+ESC, Startup tab to disable unwanted programs. Asterisk defragment your hard drive, HDD only if you're using a traditional hard drive, HDD, defragmenting it can improve performance. Windows has a built-in defragmentation tool. Do not defragment an SSD, solid-state drive, it can reduce its lifespan. Asterisk clean up your hard drive. Asterisk remove unnecessary files and programs to free up disk space. Asterisk adjust visual effects, Windows. 1. Press the Windows key, type adjust the appearance and performance of Windows, and press Enter. 2. Select adjust for best performance. 3. Optionally, re-enable specific features that you find essential, such as smooth edges of screen fonts. Asterisk game mode, Windows enable game mode, settings gaming game mode. This prioritizes system resources for gaming. Asterisk NVIDIA control panel / AMD Radeon settings. Asterisk these panels offer advanced settings that can affect performance. Asterisk power management mode, NVIDIA set to prefer maximum performance. Asterisk texture filtering quality. Asterisk set to high performance. Asterisk anisotropic filtering. Asterisk set to application controlled or disable it. Asterisk anti-aliasing mode. Asterisk set to application controlled or disable it. Asterisk triple buffering. Asterisk off, if not using VSync. Asterisk shader cache. Asterisk enable. This can reduce stuttering. Asterisk overclocking. Advanced overclocking your CPU and GPU can provide a performance boost, but it also increases heat and can potentially damage your hardware if not done carefully. Research overclocking thoroughly before attempting it. Automation with code, example, Python script to modify configuration files. While manual editing is essential, you can use scripting languages like Python to automate the process of modifying configuration files. This can be useful for quickly switching between different graphics profiles or for setting up multiple game configurations. Example, Python script to set the resolution in a CSGO video.txt file asterisk. Explanation asterisk. 1. Import OS module asterisk. This module provides functions for interacting with the operating system, such as finding files and paths. 2. Set _xgo resolution function asterisk. This function takes your Steam ID, desired width, and desired height as arguments. 3. Construct configuration file path asterisk. The script dynamically constructs the path to the video.txt file using os.path.join and os.path.expand user, to handle different user accounts. You will need to adapt this to the correct path for your system. 4. Error handling asterisk. The script checks if the configuration file exists before attempting to modify it. 5. Read file content asterisk. It reads the entire contents of the video.txt file into a list of lines. 6. Find and modify lines asterisk. The script iterates through the lines, looking for the lines containing setting.defaulters and setting.defaultReshanked. It then replaces these lines with the new resolution values. 7. Write modified content asterisk. The script writes the modified list of lines back to the video.txt file, overwriting the old content. 8. Error handling, try, except. The script uses a try, except block to catch any potential errors that might occur during file reading or writing. 9. Example usage asterisk. The script includes an example of how to call the function with your Steam ID and desired resolution. Remember to replace 12345678 9 with your actual Steam ID. You can find this ID on Steam by enabling Display Web Address Bar in the Steam client settings and then visiting your profile. The number in the URL is your Steam ID. How to use asterisk. 1. Install Python asterisk. If you don't have it already, download and install Python from https://www.python.org/download/ https://www.python.org/downloads. 2. Save the script asterisk. Save the code above as a .py file, example set_resolution.py. 3. Modify the script asterisk. Edit the Steam_ID, new_width, and new_height variables to match your Steam ID and desired resolution. Also, very important, double check that the path to the video.txt file is correct for your system. 4. Run the script asterisk. Open a command prompt or terminal, navigate to the directory where you saved the script, and run the script using Python set_resolution.py. 5. Restart the game asterisk. Launch CSGO to see the changes. Important considerations for automation asterisk. Asterisk game updates. Asterisk game updates can sometimes overwrite configuration files, so you may need to rerun your script after an update. Asterisk configuration file format. Asterisk the structure of configuration files can vary greatly from game to game. You'll need to adapt the script to the specific format of the file you're working with. Some games use more complex formats like XML or JSON. Asterisk regular expressions. Asterisk for more complex configuration files, you might need to use regular expressions to find and modify specific settings. Asterisk backup and restore. Asterisk always create backups of your configuration files before running any scripts that modify them. You should also consider creating a script to restore the original configuration if something goes wrong. 6. Additional tips and tricks asterisk. Lower monitor refresh rate asterisk. If your monitor supports multiple refresh rates, example 60 Hz, 75 Hz, 120 Hz, 144 Hz, try lowering it to 60 Hz. Higher refresh rates require more GPU power. Use a performance monitoring tool. Tools like MSI Afterburner or the built-in performance monitor in Windows, Task Manager Performance tab, can help you track your CPU and GPU usage, frame rates, and temperatures. This information can help you identify bottlenecks and fine-tune your settings. Run the game in a window. Running the game in a windowed mode, especially at a lower resolution than your desktop resolution, can sometimes improve performance. Borderless windowed mode is often a good compromise. Disable full screen optimizations. Windows right-click on the game's executable file, go to Properties, then Compatibility, and check the box Disable full screen optimizations. This can sometimes resolve performance issues. Upgrade hardware. Last resort. If you've tried everything else and you're still not getting acceptable performance, consider upgrading your CPU, GPU, or RAM. Even a small upgrade can make a significant difference. Prioritize upgrading the GPU first. Linux. If you're technically inclined, consider switching to a lightweight Linux distribution. Linux is often more resource efficient than Windows, and can provide a performance boost, especially on older hardware. Distributions like Lubuntu or Subuntu are good choices. 7. Conclusion. Achieving maximum FPS on low-end hardware requires a combination of in-game settings, configuration file tweaks, OS optimizations, and a willingness to sacrifice visual fidelity. By carefully adjusting these settings, you can often transform an unplayable game into a reasonably enjoyable experience. Remember to experiment, Be patient, and always back up your configuration files before making any changes. Good luck, and happy gaming, at Potato Settings.